Okay, we're going to finish up with a nice predictive tool that's related somewhat to linear regression. It's called time series. Time series are becoming much more important now that we have the computing power to do a lot more analysis with them. We're going to just give a brief overview. We're not going to go into the technical details that we were planning on with the changes in the semester. So we're just trying to give you a flavor that they're out there and that there's some interesting and useful analysis you can do with them. So let's take a look at time series. It's different from standard linear regression because the data are not necessarily independent and they're not identically distributed. And the thing that does involve is a list of observations where the ordering matters. And order is very important because there's dependency, and changing the order could change the meaning of the data. Now, we don't have all the assumptions that we have with our linear regression, but it's helpful for us to build a model based on that. So the objective of time series is to describe the important features of the time series pattern, explain how the past affects the future, or maybe how they could interact, maybe to forecast future values of the series, and to possibly serve as a control standard for a variable that measures the quality of product in some manufacturing situations. So if you're in systems or in some sort of manufacturing process, time series are helpful in determining how you're going to change your quality control or something along those nature in manufacturing. So there are maybe two broad types we're going to talk about. One is smoothing methods. One is Irregular models, which we're not really going to talk about. These are autoregressive integrated moving average. And this relates the present values to the past values and past predicted errors. You'll see this on Minitab, but we're not going to be able to go into where it comes from or how it comes in. Essentially, what smoothing methods try to do is smooth out the irregular components, but they don't assume there's a trend or a seasonal component. Now, the ordinary regression models use time as the x variable, and they are helpful in initial description of the data, and they form the basis for simple forecasting models, and they estimate the components. Well, we'll see the trend, seasonality, components, and irregularity shortly, but the components is the basis for building the models. There's a way that you can analyze them a little bit better to get a better model. So here's some time series uses: economic forecasting, sales forecasting, budgetary analysis, stock market, yield projections, workload projection, utility study, census analysis, all those types of things. With time series in particular, you have to be a little careful of extrapolation. Sometimes what is the past may not be the future. However, there is a benefit to this if you have the idea that, well, if things continue this way, this is what's going to end up happening. So those are some benefits, and predictions are just predictions and should not always be taken as gospel. Some other possible uses: to plan inventory, scheduling, understanding the seasons, the time of the year, effect on your business, develop advertising campaigns, and forecast profits, and plan corporate strategies. So this is actually a pretty big deal. There's a little subtlety, which is why it's not necessarily at the introductory or even the advanced statistics level. There's entire courses on time series. So here's the questions you look at first. Is there a trend? Do they increase or decrease over time? Is there seasonality, meaning there's kind of a regular repeating pattern? Are there outliers? Again, are there long-run cycles or period unrelated to seasonality factors? And is there a constant variance, or is the variance non-constant? Or are there abrupt changes? And that, again, is something that can help us look. So here are the components that we talk about: the trend component, the seasonal component, the cyclic component, and the irregular component. So first of all, let's talk about what a trend is. It basically is what's the direction of the curvature. If there is no particular trend over time as a relatively constant mean, we call that stationary in the mean, and we could use regression. We'll do this later. Stationary in the mean is an important concept. We just can't go into it as detailed as I would like. Then there's also the seasonal component, like every March, suntan lotion goes up, or tanning booths explode. I mean, it's things like this that might happen. I guess if you're fair complected and want to brown and get skin cancer. Variation that fluctuates weight that is roughly stable over time with respect to timing, direction, and magnitude. And so basically, maybe it's deseasonalized. Maybe you remove the seasonal trend and see what's going on. You try to find the period between seasonal components. And then the cyclic component is the regular cycles in the data that may be longer than 1 year. Maybe every 7 years something happens. And the residuals will be important. And this is what we call the irregular component. And again, there's this thing called stationary invariance, which is when you have relatively constant variance. We're not going to be able to get into it this year. So here we have the whole food sales by quarter. This is in the mid-thousands. And so here you can take a look at it, and you can see there's kind of this strange seasonal trend. It does look like it's going upward. Let's kind of answer those questions. So the trend, you could say, well, it's positive and nonlinear. And maybe the rationale is the overall increase in sales, and maybe it's positive and concave up. Maybe the seasonal, it seems to peak every first quarter. Maybe it's larger sales in the first quarters. We really don't know at present. And the period length seems to be yearly for what happens. And their cycle, there doesn't really seem to be much. There was a 2008 downturn that's not in here. They divested of this thing called wild oats. I mean, remember that. Maybe there's some economic cycles, inflation, interest rate, maybe employment. The employment rate might affect consumer spending. We just don't really have any expected period length unless you want to go with the 100-year flood kind of ideas. And there's really no random fluctuations in data. You know, maybe there's just irregular events or unpredictable events such as merger acquisition, natural disasters, and no regular repeating periods or patterns. So those are the things we could do, and we're going to talk a little bit about modeling the time series here. Let me just kind of show you what you could do with the Whole Foods, how you might be able to do that. Just do stats, time series plots. Let's do a simple one, and we want to do the year for the sales. We want to do sales. If we go ahead and graph that, we get this idea of that repeating pattern. One thing that we can also do, that once we have this, we have a variety of different things we could do, like a trend analysis. Maybe we'll do a linear. Of course, we need to have the right variable that we're looking at. We could take a linear trend at it, and we kind of looks up at it, kind of underestimates and overestimates that, but we get an equation up here. We could also do another trend analysis, maybe exponential growth, because maybe it's growing more like a percentage, and we could do it there, and that seems to be a little better, and it looks to be growing at 1.0463 or maybe 4.6% per year in sales. There are other things you can do with the time series here. You can do a moving average, do sales again with the length of moving average of 4. What that does is it averages the 4 and kind of gives you a curve. The thing about this is it's using the previous 4. So if I wanted to get, you know, maybe something more consistent with the data, I could do a moving average and click on the centered moving averages. So it takes the 2 previous and the 2 in the future. And that way it looks a little bit better. Otherwise, with an increasing trend, it'll always lag behind. So this is an introduction to time series, and I hope you at least get a little grasp of the power of time series. And we'll do a little bit more essentially in the future. Maybe with time series we'll predict how many videos there will be with this. I don't know.